Hi everyone. So in this lesson today, we're going to learn about rational numbers, and these are our objectives that you see in front of you. What is a rational number? What is an irrational number? So you need to know some vocabulary, how to graph them on a number line, and identifying squares and square roots and cube roots. As we go through this video, you should pause me to take notes and write down as if you would in the classroom when we're talking. This is the presentation that you would have seen. Okay, so first, we just need to do a little bit of refreshing from pre-algebra. You should have learned the natural numbers are 1, 2, and 3. Those are your normal counting numbers. You learned these starting in preschool. You might not have known they were called the natural numbers, but you have 1 crayon, you have 2 crayons, you have 3 crayons. Whole numbers is when you learn about 0, 0, 1, 2, 3, 4, and so on. Negative numbers are first introduced in the integers, -1, -2, -3, and so also going 0, 1, 2, and 3, and so on. However, if you notice in these 3 sets so far, we don't have any pieces. We don't have any fractions or decimals, and that's where the rational numbers come in. So what is a rational number? It's a number that can be written as a ratio, like a fraction, a over b, where a and b are integers, meaning they could be positive numbers or negative numbers. They're not decimals, they're integers, and b cannot equal 0. Okay, so can a or b be fractions or decimals? Inside your fraction, can you have fractions or decimals? The answer is no. Also, can a equal 0? Can the numerator, our top number, can that be 0? Well, if you think about it, if 0 is on the top of a numerator, top of a fraction, that just means it equals 0. When you have a fraction, if you have 0 over 2, that just means 0. So if 0 is in the numerator on top of a fraction, it just equals 0. However, if 0 is on the bottom, if it was 2 over 0, this is a number that is undefined. We do not have a definition for it. So that is why you cannot have, sometimes it connects as I'm writing. That is why you cannot have a denominator with 0. A quick way to remember this, that I'll probably have a poster up in the room, is that it's okay when the 0 is on top. It is not okay when the 0 is on the bottom. So okay versus no, it's not okay when the 0 is on the bottom. Okay, so what you need to do is write down these numbers that I have listed here down at the bottom. And what I'm going to do is I'm going to drag them up to either a yes or a no. Are they rational or not? So if they're rational, I just told you the definition was that they can have a fraction. They can be written in the form a over b. So let's look at this list. First of all, easy enough, 8 over 3, that's a fraction already. It's a over b. -1/5. 1 over -5. You should also know that these two numbers are the same. It does not matter. Oh, it's not letting me put it. There we go. They are equal to each other. Doesn't matter where the negative is, if it's on the top or the bottom or in the middle. So these are all fractions so far, which means they're all rational. Okay, if we look at this one, this is a mixed number, but you can actually write that number as -4 over 3. So yes, it's just this is a different name for it. Same thing with a half, 0.5, that can be written as 1 over 2. So far, these ones are all rational. Now we got to look at these. These are square roots. The square root of 4 equals 2, and 2 can be written as a fraction. So this equals 2, and 2 can be written as a fraction, 2 over 1. So yes, that's rational. The square root of 5 is not rational. It's actually called irrational. We're going to learn about that in a second. If you were to take the square root of this number, it would be a decimal that goes on forever and it never repeats. Same thing with 6. So now you have some examples of what rational and irrational are. So let's look at some algebra behind this. Are these numbers that I've given you algebra now with the variables, are they rational? Well, 1 over a number x. Well, as long as x doesn't equal 0, this is a rational number. So we just have to fill in that as long as x doesn't equal 0, we're good to go. Now here, this could be a rational number, but you have to think, x cannot be what? So you want to think about the denominator. We do not want the denominator to be 0. So x cannot equal, I deleted both, cannot equal -1, because -1 plus 1 in the denominator would equal 0. Okay, same rationale for the third one here, going down the column. But remember, the numerator can equal 0. That's okay. It's the denominator. So you need to look at this bottom number here, and we have x plus 2. So you have to think, what can x equal that would make that whole thing equal to 0? And we don't want that to be the case. So then it would be -2. X cannot equal -2. Okay. In my last one, this one's a little trickier. There's actually 2 things that x cannot be, because then it will make the denominator equal to 0. And the first one is 0. Oops, sorry, that's my phone. So x cannot equal 0. And if you think about it, because basically if I plugged that in, it would be 0 times 0 plus 1, which is 1. That still equals 0. The other number is x cannot equal -1, because it would be -1 times -1 plus 1, which is 0. So those are the 2 numbers that x cannot equal in order to keep that rational. Okay, moving along. What is an irrational number? A number that cannot be written as a ratio, where a and b are integers and b cannot equal 0, is irrational. So it cannot be written as a fraction. In its decimal form, an irrational number is a decimal that is not repeating and not terminating. Oh, okay, so what all of that means, not repeating means it doesn't continually have the same thing where you could put the bar over it, the radicand. Not the radicand, where you can't put the little bar over it, the bar notation. And non-terminating means it doesn't end. So it goes on forever. So an example of what that means is a decimal form, 0.1237709, and so on. Okay, it's just a number that goes on forever. Some other important points is anything that's not a perfect square, and we're going to talk about those in a minute. Square root of 15 is an example. That's irrational. A negative number under the square root is also irrational. And this is actually called imaginary numbers. And that's something you learn about in high school. And we might talk about it briefly this year. But there are things called imaginary numbers that you have yet to learn about. And it has to do with a negative number under the square root or the radicand. Okay. Next, when a radicand is not a perfect square, radicand is just the number that's underneath our square root symbol. That's just a word for that. The number is irrational. So 5, 6, 7, and 8, the square root of each one of those is not a perfect square. If you were to type them in the calculator, you'd get a decimal going on forever and never repeating. So it's non-terminating, non-repeating. However, the square root of 9 equals 3. 3 times 3 is 9. There's a whole number times itself that gives me that 9 underneath. For these ones up top here, each one of these, there is no whole number that I would multiply times itself to give me the number underneath. Like 4 times 4 is 16. So the square root of 16 is a perfect square. Okay, but each one of these up there, and it continues to go on. Pi is a famous irrational number, so that's one you'll typically see. You should know that pi goes on forever. Yes, 3.14, but that's just an abbreviation. Pi does go on forever, and it doesn't repeat. Okay, when we're graphing on a number line, I just wanted to quickly point out, you need to draw a number line for the length that you need. It doesn't necessarily need to be super large. It doesn't need to be as long as this. You need to make sure, now this program doesn't do it, that you put arrows on both ends, so that's something that's important. And when you plot it, when you figure out where it is, you should put a dot and you should label it with where you're putting it. What I mean, let's do -1 1/3. Well, I know that that's between -1 and -2. It's closer to -1. So I would put, let me just change my color here. I'd put a little mark like right there, and then I would label it here, like that, and you could put a tick mark now. Yeah, that's kind of lining up. There we go. And put a tick mark and put a dot and show exactly where it is. The square root of 4 we know is equal to 2, so you would put it right here, and you could put a dot. Oh, the program isn't letting me. There we go. And put a line. Okay, so as we put it in, you should put a dot. You should label where you're putting it. The square root of 6 is in between 2 and 3. So we would put a dot here, and then you would bring it down. Now my dot is not seeming to be working on this program for a minute, so that's okay. There we go. Oh, 2 dots. Well, I'll erase that one. And there we go. So you just need to label as you're doing it. Very important. Okay, so what is a perfect square? So let's talk about that. Perfect squares, they make a square. 2 times 2 is 4. 1 times 1 is 1. 3 times 3 is 9. X times x is x squared. 2 times 2, or 2 squared, is 4. 1/5 times 1/5, when you multiply them, 1/5 squared, is 1/25. 0.3 times 0.3, 0.3 squared is 0.09. So square root is the opposite operation of squaring. Now you're only looking for the positive root. What I mean, the square root of 4, what number times itself is 4? That's 2. Square root of 16 is 4. The square root of 1 over 36, well, 1 times 1 is 1. 6 times 6 is the 36. Here you got to think about 121. What's that perfect square? 11, and then you have to use your decimal, 0.11. These are all rational numbers because they can all be broken down to fractions or whole numbers. Cube roots are just 3 times. X times x times x is x cubed. 2 times 2 times 2 is 2 cubed, which is 8. 3 cubed is 27. 1/3 cubed is 1 over 27. And realize that the opposite, if I took the cube root of 8, you get 2, because 2 times 2 times 2 is 8. The cube root of 1/8 is 1/2. And so on. Okay, so these are all cube roots, square roots. Okay, and that is it. We're going to memorize these and write them all down. Other than that, I hope that you have a great one. All right, bye-bye.